Hi guys, it's Miss Leslie and I'm come to you with a video on transformations. I believe transformations is kind of new for all of us, so I wanted to make sure that before you delve into the pre-assessment, I give you guys some background knowledge on what transformations are. Now guys, there are three types of transformations. You have rotations, reflections, and translations. And as we go through each one, I'm going to talk about what it should look like on our trusty little coordinate plane right here. Doesn't look like much, but I think that you guys will get the idea of what each one of these transformations are, okay? So guys, there are a couple things that you need to remember when you're talking about having squares or rectangles or triangles on the coordinate plane to do rotations, reflections, and translations. First thing that I want to make sure that we make note of is your axes. Guys, please remember that there are two axes that make up a coordinate plane. You have the x-axis that runs left and right, and you have the y-axis that runs up and down. And in the middle, we know that we have the coordinate 0, 0, which is called the origin. That is so important when you're talking about translations, rotations, and reflections. All right, guys, so the first thing I want to do is explain what each one is, and then I'm going to show you an example of each, okay? I've already got my definitions written down, so I want to make sure that I'm not skipping over anything. All right, so guys, first thing that I want you to know is what a pre-image is. A pre-image is an image before its transformation. Okay, so guys, I've got my little rectangle right here, and what will happen is that my rectangle will start off somewhere on my coordinate plane, okay? It's the pre-image. I haven't done anything to it yet. It's just right here, and I haven't moved it yet, okay? Guys, whenever you're looking at a pre-image or any image, you can always tell what the image is because each vertex or each corner will have a name. So the name of this rectangle is rectangle A, B, C, D. And it's the pre-image because it hasn't been moved yet, okay? Now, let's talk about what a prime image is. A prime image is an image after its transformation. So what we would do is we would take the pre-image and we would either translate it, rotate it, or reflect it. And after it has been translated, rotated, or reflected, it is what is called the prime image, okay? So let's say I took this rectangle and moved it from here to here. Well, this was its original, that's the pre-image, and this is the new image, it's the prime image. This rectangle has been moved from the first quadrant of the coordinate plane to the fourth quadrant of the coordinate plane. And guys, you can always tell which one is the old one and which one is the new one because the prime image will always have a little apostrophe right here in the corner. See? This is A prime, B prime, C prime, D prime. Same image, it's just been moved from here to here. This is the old one, A, B, C, D, but after it was moved, it was A prime, B prime, C prime, and D prime. All right, guys, so let's talk about each type of transformation. First transformation that you guys need to make sure that you know is a rotation. A rotation, guys, is just the way that it sounds. It is a 90-degree movement around the origin. Okay, so I'm going to take my image, this rectangle, and I'm going to place it in the first quadrant of the coordinate plane. A rotation is a 90-degree movement around the origin, okay? Guys, you know the way that a clock moves, we call that clockwise, which is from right to left. But when you're talking about rotations, rotations are always counterclockwise from left to right. So every time we move this rectangle from one quadrant to the other, it's going to change its orientation, which means it's going to change the way it looks from here to here, then another 90 degrees from here to here, then another 90 degrees from here to here, and then another 90 degrees back from here to here. Let me show you guys what each rotation looks like. Here's the pre-image. I'm going to move it 90 degrees. When I move it 90 degrees, it's going to go from here to here. That's one 90-degree rotation. Okay, now I'm going to move it from where it is to right here. And see, when I move it, look what happens. It's moving around the origin. That's called 180-degree rotation. Then we would move it again. See, this vertex is going to stay on the origin. It's going to move again. That's called a 270-degree rotation. And then if I move it back another 90 degrees back from where we started, look, that's 360 degrees. So you can see it moved from here to here, 90, 180, 270, 360. This vertex that's right here in the corner never really moved. It just traveled around the origin. That's why we call it a rotation, a 90-degree movement around the origin. Okay? So guys, if you see that your shape has been moving around the origin and it's changing its orientation, which means it does not look the same as when it started, that's called a rotation. Okay? All right, let's look at the next kind of transformation. The next kind of transformation is called a reflection. And yes, it's just like a reflection that you would see in the mirror, which means everything that it is in its beginning will become its opposite. Okay, so I've got my rectangle right here that's in the first quadrant of the coordinate plane. There's only two ways that you can reflect an object. You can either reflect it across the x-axis or you can reflect it across the y-axis. So if you're reflecting across the x-axis is the mirror. Okay? So if this rectangle is looking in the mirror, then its image will look like this. Because remember, it's just looking in the mirror at itself. The x-axis is the mirror, and the prime image will be on this side. Okay? Now, let's look at a reflection across the y-axis. Again, guys, here's your pre-image. This time the y-axis acts as the mirror, and the rectangle is going to see itself on this side this time because the y-axis is the mirror. So if he's looking in the mirror, he's looking at himself on this side. So that's what a reflection is like. Okay, guys, the last type of transformation is called a translation, and I just like to call that a slide, because translations is just a movement in either of the four directions. It's either going to move up or down or left or right. But the good thing about a translation is that it does not change its orientation. The translation is the only one where the image will look exactly the same. It's just been slid either left or right, up or down. Here's an example, guys, of us translating this rectangle. See, it's here, but if I were to translate it, I would just move it here. See, it slid down and then it slid to the left. But did it turn? No, not at all. Okay, here's another example of a translation. Let's say that the rectangle was here and it lied directly on the y-axis. If I said that it slid down, then it would go from here maybe to there. Okay, did it change? Did it turn? No, not at all. It just slid directly down. Okay, so guys, let's go back to the three types of transformations one more time. Guys, remember that a rotation is a 90-degree movement around the origin. So it's going, one vertex is going to stay where it is. It just continues to move like this. Remember that a reflection is just a mirror image, and the mirror acts, whatever the reflection is, that axis will act as the mirror. So if we were reflecting this image across the x-axis, it would be here. If we were reflecting this image across the y-axis, it would be here. And remember, guys, that a translation is just a slide. in either of the four directions, north, south, east, or west, but it does not change its orientation. So the image would go from here to here, or to here, or to here. But notice that it's the same way that it always was. Okay, guys, I'm uploading this video to see if this will help a little bit before you guys take your pre-test. And I will show you a little bit more on translations on how best to do that in the next video. All right, guys, have a good night.